So good morning again, and welcome to the AI Program Showcase. My name is Aida Mehonic. I'm Program Manager for the AI Program at the Turing Institute, and I'll be your host today. Let me just run through a few housekeeping items. So firstly, when you join Zoom, we encourage you to please add your full name and your organization or university in your screen name for our record keeping and for other people to see. Next, please note that this event will be recorded and it will be published on the Turing Institute's event webpage. So just please be aware of that if you prefer not to have your video on or anything like that. Please feel free to use the meeting chat for any general conversation. For questions though, we would like to encourage you to please use Slido, which you can by scanning the QR code, which you can see on this slide. Or alternatively, you should go to this URL and type in T159. So I'll let you just try that for a minute now. So to kick off the event, we'd like to ask you a question. And you should be able, let me go through the agenda first, sorry, Johnny. So the agenda will see us listen to Adrian's presentation for the first 20 minutes. Then we will have a Q&A with our panelists for another 20 minutes, during which we invite you to ask questions through Slido. Then we'll have a short break. And finally, we'll wrap up with quite a long networking session for 45 minutes, which is really a chance for you to come to us with any of your questions and ask panelists kind of your detailed questions and anything that's unclear. And of course, anything that kind of remains unanswered, you can always contact us after the event. So with that, let's kick off with our first question. And fingers crossed this is working for people. So which AI method do you think will be most impactful over the next 10 years? Call me impatient, but it's probably safe to say that reinforcement learning won the day for now. So I hope you've enjoyed this kind of real-time polling exercise. And let's see if you change your mind after hearing our presenters today and the discussions later. So with that, please join me in inviting our today's speaker, Adrian Weller, who is Program Director at the Alan Turing Institute. Adrian, if you could please share your screen and join me in welcoming Adrian.
Thanks so much. Can everyone hear me? Brilliant.
Yes.
And let's just make sure you can see slides. Can you see the first slide?
Yes, we can.
Brilliant. So let me reinforce Ada's message and welcome you all. Thanks very much for joining us. I hope this will be a fun and interesting time. And really our main objective is to tell you a bit about what we're doing and to see if you'd be interested to come and join with us. We're always looking for new collaborators. Well, it doesn't seem to be changing. Has that just changed? Good. So just very briefly, let me talk you through some of our key program personnel. We have lots of other people that are involved and affiliated. I'm Adrian Weller, I'm Program Director. We'll be joined just a little bit later by Mike Wooldridge from Oxford and Sethu Vijayakumar from Edinburgh, who will also speak a bit in this presentation. We have group leaders who lead on particular aspects of our work, including Ricardo Silva at UCL, who leads on causality, Yaron Gal at Oxford, who focuses on robustness, Lillian Edwards at Newcastle, who focuses on law. Unfortunately, she can't join today, but if people have questions about the legal work that we're doing, I'm happy to speak to that later on. Stefano Albrecht at Edinburgh, who helps work on multi-agent systems, and Nick Hawes at Oxford, who works on robotics. We have with us, as well as Ada, we have Nico Gurnian, who leads on our partnership development, and Serena works with Sethu in Edinburgh to help with program management on robotics. So the vision for our overall program is as written here. We want to advance world-class research in AI and its applications, aiming to ensure beneficial implications for society, building on our network's wealth of expertise. Of course, AI cuts across almost everything that the Turing does. We'll talk today about our primary areas of focus within the program. And the first one that I'll speak to is what we call safe and ethical AI. That is, we want to build the technical underpinnings for safe and ethical deployment of AI systems to benefit society. To introduce this, let me give you some context. It's an exciting time for AI. Capabilities have improved dramatically due to better algorithms, also importantly, due to more computing power and more data. This has led to powerful applications deployed all around us, including this important example in healthcare. So this is a recent article from Nature showing that for breast cancer diagnosis, in some settings, an AI system can actually surpass human experts in diagnosis. We've also seen tremendous opportunities to use AI to help battle COVID. However, deploying systems in the real world often introduces many tricky challenges. And clinicians and patients in this healthcare setting have to be able to trust these systems. This raises many important and fascinating technical issues, which we'll soon discuss. But first, I want to emphasize that our response should not be to focus just on building trust. Trust is a human feeling that needs to be properly earned. If there's too much, it can be abused to take advantage of people. So that's why, as Honora O'Neill has often said, we must build systems which are trustworthy. We need reliable measures of trustworthiness in order to build the safe and ethical systems that we want. And we must recognize that notions of ethics, trust, and trustworthiness are inherently sociocultural. They can't be solved just by addressing AI systems. In fact, over the last few years, we've seen many different lists of AI ethics principles that were published. So let me show you an analysis of some of them. This is from 2019, when there were just 84 ethics guidelines that were being published. They're now well over 100. We'll see that there's good news in that there's a lot of overlap in what the different guidelines indicate is important. This is a summary, and you can see that there's convergence on several primary ethical principles, including high up, transparency, justice, and fairness, and various other ones. Now, these ideas, of course, are good things. But as already suggested, if you look on the right of the table, where you see many different words used, for example, at the top, you can see transparency, explainability, disclosure, and many other words. These ideas can mean many different things to different people in different settings. To make progress from these principles to practice, we'll need to look at concrete settings where precise meanings become clear, where we understand who needs what and where the inevitable interdependencies and trade-offs are apparent. As one example, it's easy, if you think about it, to see how the privacy of an algorithm and its data might be at odds with full transparency. Oops. Sorry. That is, as we think about the socio-technical issues, we have to address questions such as, how was the model selected? What training data was used and why? What objective was optimized? How will the system be used and monitored? And ultimately, of course, always it's humans that are responsible for the design, development, and deployment of an algorithmic system. It's never okay just to blame a bad outcome on an algorithm, even if that's sometimes convenient. So I'd like to suggest a framework to move forward constructively from high-level ethics principles to practice. We need to focus on concrete settings, and in the near term for our program, some of the settings we'll be looking at will include healthcare and criminal justice. These are both settings with high stakes decisions where algorithmic systems are coming. We need to get them right. And what's good in these settings is there's a fairly clear outcome that we want to improve. So we know what we're trying to achieve. So this framework has these three parts. First, we need to identify the requirements, what's needed for a specific given context. Secondly, we need to build in those requirements, and that's where our program focuses. Thirdly, we need to check and enforce those requirements, working with policymakers, lawyers, to achieve good enforceable governance. Of course, this is an oversimplification. There's no point checking for something which can't be built. And when we think about what requirements are needed, we need to be informed by what's possible to build. So we need to keep iterating between these three tasks over the life cycle of system design, development, and deployment. Again, our program focuses here on the blue box at the bottom left. but we need to interface well with the other boxes to make sure that our systems do what's needed and enable good governance, which is technically feasible and legally sound. We're well connected. So just as one example, some of you may know about the UK Centre for Data Ethics and Innovation, which examines the governance landscape. I'm one of the people on the board of that organization, but as an institute, we have many connections across this space, but we're always looking to collaborate with more people and partners. So please contact us if you'd like to get involved. So now focusing on these technical issues, let me talk about some of our main research themes. Fairness, that is, how can we try to avoid inappropriate bias against individuals or population subgroups? Transparency, which includes explainable AI, algorithmic interpretability, but also includes thinking about broader questions, such as how can we be transparent about how we came up with the objective, where the data was gathered, how it was processed, topics like that. By resilience, we think about network systems. So often we'll have a situation where we want to, of course, we'd like to protect any part of the system from being compromised. But by resilience, what we want to ensure is that even if something does go wrong, the system will still keep operating well. Robustness is something a little bit different, by which we mean, how can we try to develop machine learning methods so that even though we train them in one environment, and then they might go out into the world into a range of different environments, we'd like to ensure reliable, good performance, even in settings that it may not have been trained on. By privacy, we mean typically what is meant, so how can we use methods such as differential privacy or secure multi-party encryption to try to learn powerful machine learning models while respecting the appropriate privacy of people that are involved. Security, of course, there's traditional cybersecurity, but we're particularly interested here in new forms of attack on machine learning models. So things like data poisoning attacks, where people can tamper with your data, your training data, just a little bit, that could lead to disastrous consequences when you deploy your system in the real world. And lastly, here we're showing control. That is, how can we try to make sure that the systems we develop and deploy actually really do what we as humans want them to do? And that's more complicated than it may seem. And within that, I'm also including the idea of what we sometimes call influence. That is, we want to control the systems. We don't want the systems to be unduly influencing and controlling us. I emphasize that all of these areas involve fundamental, strong technical work. We have work here that's led to lots of publications at top venues like NeurIPS, ICML, and ICLAIR. We want to build theory and methods which will be broadly useful. At the same time, we're going to look at some specific settings. Like I mentioned, these include healthcare and criminal justice. And we're interested in autonomous systems, but we're also very interested in non-autonomous settings, which are likely to be very prevalent for many years. That is, we're interested in human AI teams. So this is just an illustration to show a machine and a human hopefully working well together. But the thing is that we're often interested in how we can improve the overall decision that's taken by human plus a machine learning system. One good example might be in criminal justice, where many of you may have seen a lot of attention, particularly in the US, on systems that are being used to predict likely future crime of individuals. Those predictions are used to help inform judges about really important decisions like prison sentencing. There's a lot of work which examines the fairness of the data and the algorithm used. But of course, we want to look a bit more broadly than that. We want good, fair decisions to be taken by the judge and the machine together. So that's one particular area of our interest. And next, I'm going to ask Sethu if he'd like to speak to the robotics program.
Thank you, Adrian. I think your presentation nicely dovetails into what I want to talk about. Welcome all to the AI Showcase. My name is Sethu Vijayakumar, and I co-direct the AI program specifically focusing on robotics. And in particular, if you think about how robots, embodied systems in general, need to work in today's environment, one of the key aspects is how can we do all the things that Adrian mentioned, sort of trustworthiness, fairness, ethical use of these methods. But more importantly, how can these embodied systems be safe and robust, secure, verifiable, and explainable? So for example, if something goes wrong, can we understand why it went wrong and ensure that that does not happen again? So at Turing, we're not aiming to replicate the excellent robotics programs that exist within the UK ecosystem, but instead what we're planning to do is to really look at some of the algorithmic and data-driven challenges that arise out of deployment of robotics in these settings. So, for example, I wanted to pick out two domains or two areas where we've been looking at using embodied systems and looking at data-driven challenges for these systems. So one is robots for extreme environments, and this looks at domains ranging from oil and gas, nuclear decommissioning, to asset inspection and maintenance. And the other one, which relates to what Adrian mentioned, is in the area of healthcare and assisted living. In both these settings, the accuracy, the reliability, and verifiability of systems is significantly important than some other settings like manufacturing or traditional usage of robotics, because there's a lot at stake if something goes wrong. So let me give you sort of two examples. I hope I'm able to control this. The next slide thing is a bit fiddly. Okay, let me try.
Let me try Setu.
Maybe, yeah, that works. Okay, so the first example is in the area of digital twins and shared autonomy, and indeed one of the aspects is what do we need to ensure that systems that we build are reliable, verifiable, and work to what we desire. So going back to Adrian's point on control, and in some sense, the digital twins and the shared autonomy addresses those issues. So what I'm going to do is, maybe if I go back and give Adrian the control so that he can click through the next video. So what you'll see on the left is the robot operating in a remote site. So Adrian, if you can just click that button. Yes, perfect. And what you see on the right is a user console, which looks at what the user has access to or feedback to. And this could be in a remote site, it could be in another country, it could be in another planet. And the whole thing is, and going back to Adrian's point on autonomous versus shared systems, the idea is you still want humans in the loop, but still be able to devolve or give over the main high cognitive load elements, like avoiding obstacles, avoiding bumping into things, to the smarts in the system. And this sort of interplay between human high-level volition and control with the low-level autonomous behaviors in robots is really the challenging aspects, and doing all of these things in a verifiable and explainable way is one of the big challenges. So Adrian, if I go to the next slide, another domain is in the domain of offshore oil and gas platforms. And this can go across domains from inspection, repair, and maintenance of assets. It could be in the offshore platform, it could be for our assets like bridges and tunnels and metro systems. Again, if you click on the next video, it shows a system, an autonomous system, deploying sensors on a mock-up test site of Oxford. It's a fire training office in Oxford. And there are some of these scenarios are places where humans really don't want to be there, but the robots are best placed to do it while humans are still in control of things. And again, if you click through one more of the video, you can see not just wheeled robots, but we want quadrupeds and bipeds that can access environments and places that are really hard and harsh for the humans to be in. So this is where the kind of teaming between humans and robots play a big role. So I want to finish by putting up one slide, and this is more for the discussion. Again, Aiden, if you click through a couple of times, you'll see that there are three key aspects that we still need to worry about. We have to worry about safety and actuation in dynamic systems. It could be in software, it could be in hardware. We need to reduce the sim to real gap by building efficient digital twins. And finally, and this is to kind of the verifiable and explainable systems, More than anything, we need to understand the limitation and vulnerabilities of our deployed systems. Rather than just saying everything's going to work, we want to understand where does it fail and why does it fail in an effective fashion. Over to you, Adrian.
Thanks very much, Sethu. And actually, could I ask Mike to take over here?
Sure. So thank you, Adrian. So my name's Mike Wooldridge, and when I'm not working for the Turing, I'm head of Department of Computer Science at the University of Oxford. My research area is multi-agent systems, and so that's the area that I focus on in particular at the Turing. So if you click through, Adrian. So one of the main themes that we have in multi-agent systems at the moment is understanding dynamics. So first, what is multi-agent systems? Multi-agent systems is connected AI. It's AI talking to AI. So one of the big lessons of mainstream computer science over the last 50 years is that computer systems working alone is not the norm. When I was an undergraduate studying computer science in the 1980s, that was the kind of expectation of the programs that we built then, and the programs that we expected to encounter were programs that worked in isolation. And all the evidence of the last 40 years is that isn't the norm. The internet is the norm. Massively distributed systems are the norm. And the future of computing is surely going to lie in some space where AI systems interact with other AI systems. So multi-agent systems is simply concerned with all of the issues that arise when AI systems talk to AI systems. Or to put it another way, if I want to arrange a meeting with Adrian, why would I phone up Adrian? Or why would my Siri phone up Adrian, right? So we all have agents in our pockets now. We all carry around agents in our pockets with us, Siri or Alexa or Cortana. Why would my Siri phone him? Why doesn't my Siri just talk directly to Adrian's Siri and they sort it out amongst themselves? So that's a very basic example of what we might see in the future of multi-agent systems. But multi-agent systems raise lots of issues which resonate with the kind of things that Adrian was talking about earlier on, issues like safety and control. If these systems are going to operate autonomously on our behalf, interacting with other agents, then we want to be sure that they do this in reliable ways. And in particular, one of the very big lessons of multi-agent systems is that the dynamics of these interacting AI systems can be very problematic. You can get feedback loops which lead to highly undesirable behaviors. One real world example in 2010 was the flash crash. On 6 May 2010, over a 20-minute period of the afternoon of that day, we were having a general election in this country. But over in the United States, over a 20-minute period, the Dow Jones index collapsed and lost 15% of its value. More than $1 trillion wiped off the market in 15 minutes. Why did that happen? Because computer programs were doing the trading on those markets. It was a very large multi-agent system that essentially got out of control. Contemporary markets, the contemporary financial markets and stock trading markets and so on, are all driven by agents. They are all agents that are doing the trading on those markets. So we want to be able to understand the dynamics of multi-agent systems, and we look at two different approaches for doing that. And the first approach is agent-based modeling. The idea is you simply simulate the system. You model agents directly in the system, you simulate it, and you look to see what the dynamics are. And this scales to very large systems. So the kinds of models that we develop, where we've actually studied the flash crash and the causes of the flash crash, involve millions of agents interacting with one another. The other alternative approach is to use a game theoretic approach, an analytical approach, where you model the system as a collection of rational actors and you apply the mathematics and the computational techniques used to understand those systems. So those are two complementary different approaches which reflect very large strands of work in the multi-agent systems community. Current stuff that we're doing is, for example, working on calibrating agent-based models so that we can really be confident in the predictions that they make, modeling security scenarios where, for example, you have a bunch of security resources which, for example, are trying to defend an airport. How can you optimally allocate those resources? And we model that as a multi-agent system, come up with a game theoretic solution to that, which essentially gives you an optimal policy to be able to manage your security resources. Okay, next slide, Adrian. We have done a couple of events based on the around the AI program. So on 24th November last year, we had a one-day conference, and basically the idea of this event, AI and data science in the age of COVID, was to reflect on the experience of the AI and data scientists that have been put on the front line throughout the pandemic, and to reflect on their experience, just kind of ordinary scientists who through the ordinary course of events would never expect to find themselves put on the front line in a pandemic, but they did. And so what did they learn? What lessons did they learn? What AI techniques or data science techniques didn't work, and so on. So we had a wonderful conference. We had more than 1,600 registrations for it. I think at the peak, we had more than 1,000 people listening in. We had an amazing collection of speakers with some really extraordinary stories to tell. Many of the videos, I believe, are online, not all of them yet, because we're still getting sign off, but here are some of the speakers that we had there. We're following that up, preparing a report, which is imminent, which will reflect on that. And very shortly, we will have the AI UK conference. This was postponed from last year. It was due to take place at the end of March last year, but had to be postponed because of the pandemic. We are rebooting that this year as a virtual conference. Again, we've got an extraordinary set of speakers lined up for that. The goal of this is to showcase the very, very best of AI in the UK. So that promises to be a really, really great event. If you haven't signed up, I strongly encourage you to do so. We have all the stars in the UK AI firmament speaking at that event. Okay, thank you, Adrian.
Brilliant. Thanks very much. Thanks very much, Mike. So this will be our last slide. Really, the main point is we'd like you to come and join us. So let me tell you a few different ways you can do that. There are 5 different interest groups that we're directly affiliated with in the AI program. There's fairness, transparency, and privacy, which addresses topics across those different themes. Multi-agent systems, directly addressing the points that Mike raised so well. Robustness, so focusing on the robustness topic I mentioned, how can we train systems which will reliably perform well, even in settings which are different from those in which they were trained. AI in games, led by Simon Lucas, and a reborn privacy-specific group, which is focused on technical approaches directly to privacy that you can speak to Giovanni about, who's going to join us in a moment, who's co-leading that group. In addition to these interest groups, we have about a dozen Turing Fellow projects across 7 partner universities. And we have partnerships with different organizations, including with DeepMind, where we're focusing on work initially on fairness and privacy, with Accenture, with Chelsea and Westminster Hospital, and many more. So again, come and join us. We hope you're interested. If you are, please reach out to join one of these groups or reach out directly to any of us. Thanks very much. Let me turn off that share. Ada, are you managing this, or shall I?
Great. So now we'll switch over to Johnny's slide, Johnny's screen, to go to the panel discussion, which will take us through Slido again. Hopefully it'll be working for everyone. So now I'd like to invite our 8 panelists to please turn on their videos. Currently, they can stay on mute, but be prepared to speak shortly. And for the audience to just go to Slido and think about what they want to ask our panelists. So to start with, I'd just like to invite, our panelists will be Adrian, Seto, and Mike, who you've already met. And I would like to invite the other 5 to please introduce themselves, with Anjali Mazumdar starting, please.
Thank you, Ada. I'm Anjali Mazumdar. I'm the theme lead on AI and Justice and Human Rights. I also am co-chair of the Equality, Diversity, and Inclusion Advisory Committee. So I look at questions around how we can develop inclusive practices in the responsible development of data and AI systems to address human rights, and also how we can better do data science and AI, looking at issues from data representativeness all the way to diverse and inclusive research teams. I'll leave it at there for right now.
Great, thank you very much. And next, Ricardo, please.
Hello, I'm Ricardo Silva. I'm a professor at UCL and a faculty fellow here at Turing. I lead research on causality in many aspects of it, including applications to fairness and transport systems. Part of the idea here is that causal inference does require a lot of information from experts in the domain, how it can possibly infer cause-effect relationships, where require a lot of input from humans. So we have to develop these tools that allow this integration of human-based knowledge and computation techniques that allow us to make inferences from the data that we do have. Okay, thank you very much.
Thank you, Ricardo. And next, Sebastian, please.
Hi, everyone. My name is Sebastian Stein, and I'm an associate professor at the University of Southampton and a Turing AI fellow as well. First, thanks a lot for inviting me to this panel discussion. It's been really interesting and it's exciting to meet everyone. So my personal research is on multi-agent systems as well. And in particular, I'm interested in systems where AI agents and humans interact with each other. And like Mike was saying, this gives rise to lots of interesting dynamics as well, where the systems have to react to what the humans are doing and vice versa. I'm also associated with the UKRI Trustworthy Autonomous Systems Program, or TAS for short. And I just wanted to maybe talk about this for 1 minute, because I think it's highly complementary to what the Alan Turing Institute is doing in this topic. And also there are lots of opportunities to get involved in this TAS program, so it might be of interest to the attendees. So this is a large UKRI program that's funded through the Strategic Priorities Fund. It's highly interdisciplinary. It runs over 4 years, and it has funding of about £33 million in total. It's involving lots of universities, including lots of Alan Turing Institute partners. And in this program, we're looking at how to build autonomous systems that can benefit society and that are trustworthy by design. And that's closely related to what Adrian was talking about and what they're tackling in the safe and ethical AI part of the program. But also we're specifically looking at different perspectives to trustworthiness. So on one hand, how systems can be judged to be trustworthy objectively. So for example, using certification, governance, assurance, and so on. But on the other hand, also how they can be judged to be trustworthy subjectively. And for that, we are involving lots of stakeholders, users, policymakers, and so on. Just to mention very briefly, it is a very open program. So we're encouraging other UK universities to get involved as well. And we have a £5 million set aside to fund proposals that are sent to the TAS Hub. So these are called pump priming grants. And I encourage everyone to have a look at the website and see whether there's an opportunity for you to get involved. So the website is tas.ac.uk, tas.ac.uk. Okay, thanks.
Brilliant. Thanks very much, Sebastian. I should just add that we're really excited about this new initiative. I'm really glad that Sebastian could be here to represent it, and looking forward to finding lots of good ways to collaborate. I'm sure that lots of these will emerge. Thank you.
Okay, thanks, Adrian.
Thank you both. And I'd like to invite Nico, please, to introduce himself.
Hi, everybody. I'm Nico Gurner. I'm the Director of Partnerships at the Alan Turing Institute. So my team oversees the development of partnerships across industry, third sector, and also parts of government. In the context of today's discussion, I'm really keen to hear from participants about the kind of partnerships that they think, the Turing should be kind of pursuing and why, and not limited to the kind of non-academic side, but also thinking about actually kind of international endeavors that one could look at. And potentially you'll see what kind of partnerships that the Turing should stay well away from. So that might be a different kind of discussion, but it'll be also useful to have some clues or kind of views from participants. So if anybody is interested in discussing partnerships, and I've seen a couple of questions coming up already, very happy to discuss in the breakout later on.
Great, thank you, Nico. And finally, I'd like to invite Giovanni to introduce himself.
Hey everyone, I'm Giovanni Cherubin. I'm a research fellow here at the Turing in safe and ethical AI. My interests span machine learning and privacy. First of all, we've been looking at attacks against privacy, attacks against machine learning, and how these attacks particularly affect minority populations. And our interest is trying to understand theoretically how to prevent these attacks. And it's not very easy. But once, say, we have a fully private machine learning, that's not going to be really enough. I think we also want it to be reliable, as it's already been said by many other speakers today. And by reliable, I'm particularly interested in machine learning, which gives guarantees over its accuracy, essentially, and concretely conformal prediction methods. Now, all these methods, I believe, will help us towards building trustworthy and reliable and ethical AI. And finally, I'm also interested more in privacy aspects and security aspects of information leakage and quantifying information leakage, which, surprise, it can be done via AI or machine learning theory techniques.
Great, thank you very much, Giovanni. So now you've met our panelists, and I see that people have put forward 7 questions already. And just to remind you, you can also upvote questions if you like some of them, but don't want to ask your own question. You can just vote on the ones you like. And it seems that the top 2 questions have both concerned sort of, well, there was one on legal aspects and one on criminal justice. Well, it keeps changing now that I've reminded people to vote. But let me start with the one that Jose has asked. So I think this should be probably for Anjali. The question concerns the legal aspects of, I suppose, fairness. Are you just looking at data, or are you also interested in things like accountability or negligence? And Anjali, I wonder if you wanted to take this question.
Sure. Yes, so we are interested in not just the data aspects, but the broader sort of AI issues. So this includes issues around necessity and proportionality of the systems, but also issues of redress. So and we think about these things both at an individual level as well as a population level. We have a project which is in a collaboration with Ada Lovelace Institute, the Bingham Center for the Rule of Law, which is looking at good governance for data-driven technologies in public health emergencies, such as the current one that we're in. So again, how does this relate to contact tracing apps, to immunization passports, and across, again, the legal and the technical? How do we bring those issues together?
Can I just add?
I don't know if Adrian wants to jump in there too.
Thanks very much, Anjali. I'll just add a few brief comments and we can discuss this more later. Obviously, there's a lot to say about this, but yeah, broadly, we are very interested in legal aspects. The sense in which we're interested in ethics in our program, of course, we want to be connecting with ethicists, philosophers in that way, but our primary interest is really in figuring out what is going to make sense for society. And of course, we don't have the answer to that. It involves speaking and connecting with lots of different groups and trying to have a transparent conversation about that. But once we can figure something out, we want to help make that a legal or a regulatory reality. So this involves actually examining what the existing governance landscape is and potentially thinking about how it should be modified or altered. And just as a reminder, we have Lillian Edwards, who's a professor of law in Newcastle, who's a group leader on our legal efforts, but we're really pleased to be in touch with a range of other great lawyers across the country and happy to talk a lot more about this topic if you're interested.
Great, thank you, Adrian. And a follow-on question, Max is asking, if, I suppose, Anjali again, could you say a little bit more about the criminal justice project, and specifically, how are you modeling what is a good and fair judgment in this context?
I don't know if Adrian, you want to pick this up first.
Okay, sure. So of course, we don't have the answer again. It's something which needs to be carefully investigated. There's almost a bigger question, which is what makes a good and fair judgment irrespective of an AI system. And we have some notions of that in this country and other countries. And in some ways, we need to start to try to think about how we can sharpen our ideas of what those are in the context of algorithms so that we can really measure it carefully and see what happens over time. So initially, we're working on a kind of landscaping project to understand what the existing systems are that are used in the UK. It turns out that there actually are systems that have been used for over a decade in the UK, algorithmic systems used to help predict future crime. And we want to understand how are those used, how are they investigated, and also be engaging broadly with stakeholders to understand what exactly do we want good decisions to represent. But for sure, conceptually, we want to make sure that no group is unfairly biased against. And there's certainly evidence that is suggestive that that might be happening in some settings, but we really want to dive into the details and explore it carefully. Angelique, did you want to add anything to that?
I mean, I guess I can just add that, you know, in terms of the context, we've been looking at things like parole board decision-making, so the risk assessment tools all the way to facial recognition, to predictive policing, which brings about different issues in terms of both the technical remits of what those areas of challenge might be in terms of fairness, and what we would need to look at. And again, that intersects with what are responsible thresholds for it.
Great, thank you both. And if we move on to the next question, slightly facetious, whether 2020 was a bad year for AI, and was it a bad year in particular for AI ethics? I don't know who wants to take this question. I'll let you volunteer.
Can I mention one thing quickly and anyone else can jump in? I think it's a really interesting question because it was a year where I think the involvement of AI and perhaps algorithms in decision-making became quite a bit more public. So the public's become more aware of it. And that's, I think it's a good thing to have awareness, but actually I think the publicity around it was handled really poorly, and it's a great shame. So there was the whole fuss about what happened with Ofqual and GCSE and A-level grades, which clearly caused a lot of upset. We almost had a slide actually in our deck where showing people, people might have seen these incredible scenes of students chanting, F the algorithm, F the algorithm. And around the same time, we had the Prime Minister saying that maybe it was the result of a mutant algorithm. And I think that's really, really unfortunate. We need to help push back against that and really insist that no, it's always humans behind the algorithm development and deployment who are responsible. It's not okay just to blame the algorithm, even though it might be politically expedient. And there's a risk that if that message is picked up by the public, it could create a backlash, which would be really unfortunate because there's so many great opportunities to do good things. Anyone like to add to that?
Oh, no, I can come in. I'm not sure I have anything greatly more profound to say than what you just did, Adrian, but I think the Ofqual example is a very nice example to illustrate actually you don't need AI to get things wrong in this sense. I mean, there's and actually focusing just on AI as if it is some kind of magic fairy dust that's being sprinkled over things to make decisions, I think is the wrong emphasis. It is automation, and it's naive reliance on automation and naive reliance on bad statistics in some cases that caused problems there. I think 2020 was not a bad year for AI generally at all. There were some wonderful achievements despite the pandemic. I mean, the headline achievement towards the end of the year, of course, the protein folding work from DeepMind, of course, DeepMind was one of the really big headline achievements, but there were many others, even if they didn't quite make the headlines in the same way. But I think you're exactly right, Adrian, that actually what that did is it served to demonstrate to people were being directly affected by the consequences of a poorly conceived algorithm. And the point about responsibility, you cannot offload your responsibility. You can't blame the algorithm, right? If you're the one that's deploying the algorithm, responsibility lies with you. So yeah, sorry, Giovanni, do you want to come in?
Yeah, not at all. I also was gonna say that the Ofcom is perhaps the most exemplary example. And if only 2020 brought us the understanding that we will need AI for sure, but also that we need much more testing in AI. And I think in that particular case of the Ofcom algorithm, the issue there was not as much with the algorithm, but more with the testing of the algorithm and testing, evaluating how fair the algorithm would be, how effective the algorithm would be. That's very hard, and that's where we really have to hit on and keep making progress, I think. So if only 2020 just made AI more relevant.
I see we have lots more questions on this topic, which is a great topic. There's a lot to say. Definitely, if anyone wants to talk more about those, I'm happy to take those, or Angela can take those in our breakout groups. Maybe do we have a couple of questions on other topics, Ada?
We have a few questions on other topics. For instance, what are your ambitions for the program over the next 5 or 10 years? There's also a slightly related question. If you had unlimited funding and unlimited time, what one problem in AI would you love to solve?
I can come in on that one, Ada, if you want. Yeah, okay, so this is Mike again. So what problem would you love to solve? I'm not sure that unlimited funding would solve it, although by all means give us unlimited funding. But what I would love to see is progress on two related questions. The first is that machine learning is much less efficient than human learning, right? When I learned to drive, I had, I don't know, 12 hours of lessons or something like that, and a couple of hours out with my dad on the roads. And then I took my driving test, and touch wood, I haven't had any particularly bad experiences since. Waymo are spending huge amounts of money with thousands and thousands of hours, probably millions of hours on the roads trying to get cars that can drive safely. Human beings can do learning much, much, much more efficiently than the machines can at present. So efficient machine learning in the sense of being able to do things in the same speed that human beings can do, that I think is just a huge problem for the wider take-up of machine learning. And relatedly, we've seen lots of wonderful demos of AI over the past decade or so of using reinforcement learning. For example, again, go back to DeepMind and starting with their Atari game playing programs, which could just repeatedly play these games and learn to play many of them very, very effectively. And there's wonderful demos, wonderful videos available of them doing that. But reinforcement learning doesn't work in the real world. It doesn't work in the real world because, if you're playing Atari games and you're playing, let's say, Space Invaders, it doesn't matter if you get blown up in the game of Space Invaders, you just play another game, but it matters in the real world. So how to make something like reinforcement learning work in the world, I think, is a really, really big challenge. So those are two, I think, efficient machine learning, being able to learn from very small data sets in the same way that people can, and making something like reinforcement work in the physical world, the real world, because I think the most important problems that we face are problems in the real world.
Thank you, Mike. And perhaps we could wrap up with sort of the last question now for the panel, and then go to the breakout rooms where we will continue discussions in smaller groups. So our next question on the board is probably for Nico and for the directors. So are you seeking partnerships in the program from industry or elsewhere?
Maybe I'll start, and then Adrian and colleagues can join. I mean, the short answer is yes, but not at any cost. So there's a very clear principles of the Turing as to kind of abide by is, as an institute, we have to focus on some of the big thorny challenges across data science and artificial intelligence. And Mike illustrated one potentially in a grand challenge, if I can kind of call it that. And so having kind of partners kind of willing to invest in the Turing to try to tackle some of this really, really thorny challenge in partnership is really, really helpful. What the Turing won't do is engage in kind of consultancy-like kind of relationships and arrangements for all sorts of reasons, which we can discuss further in the breakout if that's of interest to people. I think one way certainly that we have been kind of seeking collaborations and partnership in the kind of broader kind of AI space is through the means of donations. One of the reasons is because it enables the institute to kind of keep a certain degree of independence when it comes to this area, particularly if you're thinking about potential guidance and applications into the realms of standards as well. So that's definitely one element that we're looking at is if there's kind of finance-based collaborations that it has to kind of ensure that it kind of preserves the institute's independence. In some areas, it can be about the development of tools that have kind of broader appeal. So, for example, one project that we have kind of worked on with a specific foundation has been about developing a software tool that could potentially be adopted by city authorities in the world who don't have the means, for example, to buy expensive tools from private companies. So when there is a means to kind of help really impact on the public good rather than more on the needs of one or a small number of corporates, that's something that's definitely of real interest to the institute. So I'll stop there. I think I could go on. I don't know, Adrian, whether there's anything.
So I can jump in here, Adrian, quickly, and I think this is what Nico mentioned is really connected to what Mike was saying about getting algorithmic systems to work on the real world. And to make that happen, I think we need to partner with partners in the industry, because if you go back to my sort of point on living labs, this is where people who develop new methods and theoretical foundations have to work together with people who deploy them on the real world and users who specify what they want. And this, of course, along with the people who make the rules and policies. And this can only happen if you have buy-in from the industry, because I think one of the biggest problems in AI and robotics has been, there's been a little bit of a divide between what's happening in the labs and what is being developed or required in the real world in the industry. And what we're trying to do through these living labs is trying to bridge that gap by having people or industrial partners have people embedded in our labs, vice versa, our researchers going and spending some time in the lab looking at real world problems and trying to bridge that gap. And I think at Turing, at partner institutes like Edinburgh, Oxford, Sheffield, Heriot-Watt, we've been actually sort of expanding this model of public-private partnerships to work together in order to really make sure that some of these algorithms are not just papers, but actually work robustly in the real world.
Can I briefly mention about the TAS Hub as well? So for the TAS Hub, we are very actively looking for industrial collaborators as well. At the moment, and across the nodes, we have over 100 partners already. And we also really value input from industry. It's one of the cornerstones of the program. Industry partners can get involved in setting grand challenges for the program. They can get involved in writing research proposals with the academics. So we'd hope that we develop some real collaborations that make an impact through these industrial collaborations. And if anyone is interested, again, have a look at the TAS website. There's a big button at the top right where you can join as an industrial partner. Like the Turing, we have some expectations as well. So we'd expect partners to contribute to about 50% of the meetings we run, but these are really valuable. So they are, we had a co-creation workshop late last year where we designed project ideas together, and we had lots of project submissions based on that with the industrial partners on board as well.